Welcome to today's video, where we're going to tackle a common issue that many iOS developers face when working with SwiftUI, the Parallax scrollview problem in iOS 18. If you've ever tried to create a scrolling view with a parallax effect, you know how frustrating it can be to get it just right. But don't worry, by the end of this video, you'll have a clear understanding of what's causing this issue and how to overcome it. In this video, we'll dive into the world of SwiftUI and explore the concepts behind parallax scrolling. We'll break down the problem into smaller parts, examine each component, and provide examples to help solidify your understanding. By the end of this discussion, you'll be equipped with the knowledge to tackle even the most stubborn parallax scroll view problem. So, what is parallax scrolling, and why does it cause issues in iOS 18 in essence? Parallax scrolling is a visual effect where background elements appear to move at a slower pace than foreground elements as the user scrolls. This creates a sense of depth and can greatly enhance the user experience. However, when working with SwiftUI, achieving this effect can be tricky. The problem arises from the way SwiftUI handles scroll views and how it calculates the positions of its child views. But when you try to create a parallax effect by moving the background element at a slower pace than the foreground elements, SwiftUI can get confused about how to position these views relative to each other. To understand why this happens, let's break down the components involved in creating a parallax scroll view. We have our scroll view, which is essentially a container that holds all our child views. Inside this scroll view, we have our background element, which is usually an image or a color, and our foreground elements, which are typically text or other UI components. Now, when the user scrolls, SwiftUI needs to recalculate the positions of these child views relative to each other. However, because the background element is moving at a slower pace than the foreground elements, SwiftUI can struggle to determine where exactly to place these views. This results in a jarring or stuttering effect, which is far from the smooth parallax scrolling we're aiming for. So, how do we overcome this issue? One approach is to use a combination of SwiftUI's built-in modifiers and some clever geometry calculations to create a custom scroll view that can handle the parallax effect. By using modifiers like offset and scale effect, we can manually adjust the positions of our child views to achieve the desired effect. Another approach is to use a third-party library or package that provides a pre-built solution for creating parallax scroll views in SwiftUI. These libraries often provide a simple and easy-to-use API that abstracts away the complexity of handling parallax scrolling, making it easier to get started with your project. So, what are the key points to take away from this discussion? Firstly, understanding the concepts behind parallax scrolling is crucial in identifying why issues arise when working with SwiftUI. Secondly, breaking down the components involved in creating a parallax scroll view can help you identify where exactly things go wrong. Thirdly, using a combination of SwiftUI's built-in modifiers and custom geometry calculations can provide a solution to the parallax scroll view problem. Finally, don't be afraid to explore third-party libraries or packages that provide pre-built solutions for creating parallax scroll views in SwiftUI. That's it for today's video on tackling the parallax scroll view problem in iOS 18 SwiftUI. We hope you found this discussion informative and helpful in your own development journey. If you have any questions or need further clarification on any of the points discussed, please don't hesitate to ask in the comments below. If you liked this video, be sure to like and subscribe for more content on SwiftUI and iOS development. We'd love to hear from you and encourage you to engage with our community by sharing your own experiences and insights. Until next time, happy coding.